So let's start with this one. Question one. The drag force acting on a sphere falling through a liquid is given by this formula. Perfect. A drag force, let me start the recording. Recording started. The drag force acting on a sphere falling through a liquid is given by this formula, where r is the radius of the sphere. Perfect. R is the radius of the sphere. V is the velocity of the sphere in the liquid, and N is the property of the liquid called viscosity. Perfect. Show that the SI base units of viscosity are these. We have to show that the SI base unit of viscosity are these. Perfect. So first of all, what will we do? We will write the formula. Drag force is equals to 6 pi nRV. In place of drag force, now we will substitute the units of what? In place of drag force, we will substitute the unit of what? We will substitute the unit of forces. What are the SI base unit of forces? Mass into acceleration kg ms minus 2 are the SI base units of drag force. Then we are going to ignore this 6 pi. Then we are going to ignore this 6 pi. Why? Because whenever we are doing unit calculations, we ignore constants such as 6 pi, 64, whatever it is. We want to calculate the units of n, so let's put that in a different color. What will be the units of the radius? The units of the radius will be in meters. What will be the units of velocity? The units of velocity or speed will be what? ms minus 1. Perfect. What does your answer comes out to be? kg ms minus 2 divided by meter square s minus 1. What does your unit of velocity viscosity comes out to be? kg meter 1 minus 2 second s2 plus 1. This comes out to be kg m minus 1 s minus 1. Is this what we had to prove? Yeah. We have successfully proved the units of viscosity. Kg m minus 1 s minus 1 is your answer. Let's further move ahead. A sphere has a radius of 3 centimeter and is falling vertically downward at a terminal velocity of 2. Perfect. The drag force acting on the sphere is this. Perfect. Calculate the viscosity of the liquid. What will we do? We will again use the same formula. Drag force is equals to 6 pi nRV. Perfect. Let's make viscosity the subject. N is equals to the drag force divided by 6 pi R into V. What is the drag force? 0.069 divided by 6 pi multiplied by the radius. Now the radius is in centimeters. You have to convert it into meters. 3 into 10 raised to the power of minus 2. Perfect. Multiplied by the velocity, that is 2. What does your n comes out to be? What does your viscosity comes out to be, beta? 0.085. This is your answer for viscosity. 0.085 kg m minus 1 s minus 1 is your answer for viscosity. Simple. You can also put this in the calculator and calculate the answer. The sphere is shown in figure 1.1. Perfect. This sphere is shown in figure 1.1. On figure 1.1, draw and label arrows to represent the direction of the three forces acting on the sphere as it falls at terminal velocity through the liquid. Perfect. So, first of all, what will be the most obvious force acting on the sphere? The weight that is acting downward. Perfect. Now, since the object is falling downward, where will the viscous drag act? बेटा अगर कोई चीज डाउनवर्ड फॉल कर रही होती है viscous drag will act upward. What about upthrust? Upthrust will also act upward like this. These are the three forces that you had to mark here. Weight acting downward, upthrust acting upward, viscous drag acting upward. Why? Because you are falling downward. Viscous drag always opposes the motion. Let's further move ahead. The density of the liquid is this. Show that the upthrust acting on the sphere is 1 Newton. Perfect. You are given the density, you have to calculate the upthrust. How will you do that? Upthrust is equals to density of the fluid multiplied by the gravitational field strength multiplied by the volume. Perfect. So how are you going to do this? You know that the density of the fluid is what? The density of the fluid is 920. The gravitational field strength is 9.81. Now, what about the volume? Volume कैसे निकालेंगे बेटा? How will we calculate the volume? If you notice, what is this? This is a sphere. This is a sphere. And are you given the radius of the sphere? Yes. The radius of the sphere is 3 centimeter. Beta, you are given the radius of the sphere. You have to calculate the volume of the sphere. किस तरह निकालोगे volume? Volume is equals to 4 over 3 pi r cube. What is your radius? What was your radius? अभी देख के आए बेटा ऊपर. What was your radius? 3 centimeters. Let's convert it into meters. Let's convert it into meters. This comes out to be 3 into 10 raised to the power of minus 2 whole cube. Can you guys calculate the volume here? Yeah, very, very easy. 4 divided by 3 into pi multiplied by 0.03 ka whole cube. This will come out to be, this comes out to be 1.13 into 10 raised to the power of minus 4. 1.13 into 10 raised to the power of minus 4 meter cube. So you multiply the volume here beta 1.13 into 10 raised to the power of negative 4. अब ये सारी चीजें मल्टीप्लाई कर दो और अपना अपथ्रस्ट का आंसर निकाल लो. लेट्स सी व्हाट द आंसर कम्स आउट टू बी. The answer comes out to be roughly 1 Newton. This is what we had to prove. Beta, the answer comes out to be roughly 1 Newton. This is what we had to prove. Simple. Now, you have to calculate the mass of the sphere. Beta, mass of the sphere निकालने के लिए you have to understand 2 to 3 things. You have to understand that the sphere is falling at terminal velocity, or you can say at constant velocity. If you are falling at constant velocity, the downward force, that is weight, will be equal to what? Upthrust plus the viscous drag, or you can say the drag force. Let me label is that drag force के जो initial symbols थे वही लिख देता हूं मैं. Your weight will be equal to the upthrust plus the drag force. Do you have the drag force, beta? Drag force given है, yes, 0.06, 0.096 Newton. Are you given the upthrust? Yes, 1 Newton. Can you calculate the weight? Yes. बहुत easily weight calculate हो जाएगा. 1 plus drag force क्या थी बेटा? 0.09. Drag force थी 0.09. Yes. 0.096. What does your weight come out to be? कोई निकाल के बता सकता है weight क्या आएगा? या सारे सिर्फ मूवी देखने आए? The weight comes out to be 1.096 Newton. Perfect. Beta, once you have calculated the weight, mass calculate karna is a piece of cake. You are on earth. How will you calculate the mass? M into 9.81 is equals to your weight, that is 1.096. Perfect. Divide कर दो बेटा. Mass comes out to be what? 1.096 divided by 9.81. What does your mass comes out to be? Mass comes out to be 0.11 kg. Simple as that. Nothing complicated here. ये बात समझ आई बेटा सबको? Yes or no? Is the first question clear to all of you? Top to bottom पूरा question clear है? Yes or no? Is this entire question clear to all of you? Give me a thumbs up in the chat if this is clear. If anything here is not clear, you can ask without any hesitation. Make sure you ask your question in the chat today. For some reason, the audio is not working, so make sure you ask your question in the chat today. Let's further move ahead. Define displacement from a point. Okay, how to define displacement? Sir, how did you find viscosity? Beta, we were given the formula. We were given the formula here. Here. Formula given tha. Drag force is equals to 6 pi. This n is your viscosity, radius into velocity. Simple. The formula for viscosity was given already. Define displacement at a point. We have to define the definition of displacement. Hmm. You can say distance from a given point, distance from a given point in a straight line, in a straight line, in straight line. Distance from a given point in a straight line. Perfect. And you can also write in a specific direction. Simple. Let's further move ahead. An object is projected horizontally at a speed of 6 ms 1 from a slope as shown in figure 2.1. Perfect. So एक ऑब्जेक्ट है जिसको हम हॉरिजॉन्टली प्रोजेक्ट कर रहे हैं at a speed of 6 ms 1. The slope is at an angle of theta to the horizontal. Perfect. The slope is at an angle of theta to the horizontal. Air resistance is negligible. What does this mean? This tells you that acceleration will be 9.81 ms minus 2. Perfect. The object lands on the slope a time of 0.71 seconds later and stops without rolling or bouncing. Perfect. So the object lands on the slope 0.71 seconds later and stops without rolling or bouncing. Perfect. You have to determine the horizontal distance traveled. How can you determine the horizontal distance traveled? Peter, do you remember that the horizontal velocity will remain constant? The horizontal velocity will remain constant. How can you calculate the horizontal distance? Speed into time. What is the horizontal speed? 6. What is the time? 0.71. What does this answer comes out to be? 6 into 0.71. ये answer क्या आ जाता है बेटा? This comes out to be 4.26 meters is your answer. 4.26 meters is your answer. If you want to give it like this, you can give it till three significant figures. If you want to round it off till two significant figures, you can write it as 4.3 meters. Both of these answers will get a correct mark. You can write your answers till two significant figures or three significant figures, you will get the mark. Now you have to calculate the vertical distance traveled by the object. Now this is interesting. This is pretty interesting. Whenever your object is launched horizontally, now this is a keyword that I have discussed multiple times. Whenever your object or ball is launched horizontally, the vertical velocity is 0. The initial vertical velocity is 0. Perfect. So we can write it here. The initial vertical velocity is 0. Perfect. The time is 0.71 seconds. The acceleration is 9.81 ms minus 2. Can we apply any formula to calculate the vertical distance traveled? Yes, I remember one formula. S is equals to ut plus half at square. S is equals to ut plus half at square. This entire thing will become what? 0. Why? Because your initial vertical velocity is 0. S is equals to what? Half into the acceleration, that is 9.81, into the time curve square, that is 0.71 curve square. That is 0.71 curve square. Can you calculate this answer? Can anyone calculate the answer in the chat? This comes out to be 2.5 meters. Simple as that, nothing complicated here. Let's further move ahead. Use your answer in part B I1 and part B I2 to calculate the angle theta. Perfect. Let's see what is angle theta. Let's see. Okay, we have this angle theta. How are we going to calculate this? Beta, बहुत easy. Literally the simplest question that you will have. Your horizontal displacement, that is displacement in this direction, is 4.3. Your vertical displacement is what? Your vertical displacement is what? Your vertical displacement, or it would be better if I draw the vertical displacement from here. Let's do it like this. Your vertical displacement is 2.5 5 meters, your horizontal displacement is 4.3 meters. Now, can you geniuses spot that this is a right angle triangle? Can you geniuses with 100 plus IQ identify that this is a right angle triangle? Yeah, this is a right angle triangle. You have to calculate this angle theta. How are you going to calculate this angle theta? Apply, you can say tan theta is equals to perpendicular, that is 2.5 divided by 4.3. Theta is equals to tan inverse 2.5 divided by 4.3. Can anyone calculate this answer? This answer comes out to be 30 degrees. This answer comes out to be 30 degrees. Let's put this answer where it belongs. Let's put this in the correct place. Oh, let's minimize it. Let's put it here. This is tan theta. Perfect. Determine the magnitude of the displacement of the object from its original position. You have to determine the magnitude. Beta, how are you going to determine the magnitude of the displacement? अच्छा, displacement क्या होती है? What have we studied? What have we studied? What is displacement? Displacement is the shortest distance between the final and the initial position. Displacement is the shortest distance between the final and the initial position. तो बेटा फाइनल पोजीशन और इनिशियल पोजीशन में यहाँ पे शॉर्टेस्ट डिस्टेंस क्या होगा? फाइनल और इनिशियल पोजीशन में यहाँ पे शॉर्टेस्ट डिस्टेंस क्या होगा बेटा? इफ यू एनालाइज this diagonal line will be the shortest distance, or you can say the displacement. This yeah, blue highlighted line, I would say. This blue highlighted line will be the displacement or the shortest distance between the final and the initial position. Perfect. तो बेटा ये किस तरह निकालेंगे? Again, geniuses, you have to realize that this is a right angle triangle and this is the hypotenuse. What can we apply? We can apply Pythagoras theorem. We can say hypotenuse ka square is equals to perpendicular square plus base square. Hypotenuse is equals to 2.5 square plus 4.3 square under root. What does this answer comes out to be? This answer comes out to be roughly 5.0 meters. Let's put this answer where it belongs. 1 second. 1 second. Let's put this answer where it belongs, somewhere here. Okay. By considering energy, okay, now the examiner has told us we have to consider energy. Calculate the speed of the object just before it lands. Perfect. We have to calculate the speed of the object just before it lands. How will you calculate the speed of the object just before it lands? How will you do that? How will you calculate the speed of the object just before it lands? If you realize, now here you have to understand some things. If you realize initially at the starting point, let's label this. I think I should remove some highlighting here. 1 second. I can remove this yellow part. 1 second. Yeah, perfect. Let's remove this as well. This as well. Okay. Let's say this is the starting point. At the starting point, your object has some amount of height. So it will have gravitational potential energy. And your object has some amount of velocity as well. So it will have some amount of kinetic energy as well. Perfect. At the starting point, you have both gravitational potential energy and kinetic energy. At the ending point, let's say this is the ending point. At the ending point, your height is zero. Your gravitational potential energy will be zero. You will only possess kinetic energy. So you can write a short little statement here. You can say the gravitational potential energy at start plus the kinetic energy at start is equals to the kinetic energy at the end. Perfect. Now let's write the formulas. What is the gravitational potential energy at the start? Mass into g into height 2.5 plus the kinetic energy at start 1 upon 2 into m into the velocity at the start, that is 6 cos square. What will be the kinetic energy at the end? 1 upon 2 m into the velocity at the end square that we want to calculate. We have to calculate the velocity at the end square. Now, a student who gets confused easily will ask, sir, मास तो गिवन नहीं है, मास तो गिवन नहीं है, मैं कैसे सवाल करूंगा ये? Beta, you can realize that mass is common in all three terms. You can cancel that out. Mass is common in all three terms. You can cancel that out. Now just plug and play. 9.81 into 2.5 plus 6 squared divided by 2 is 18. Multiplied by 2, taken under root, you will get your velocity at the end. Can any genius in the chat tell me the answer to this one? Yes, any geniuses that we have today? 1 second. Let me also confirm it. Plus 18 multiplied by 2 taken under root. The velocity at end comes out to be 9.2. बेटा आखिर में velocity आपकी 9.2 ms minus 1 आ रही है. Literally the easiest question of the lot. अच्छा, now I am zooming out. पूरे सवाल में बेटा कोई मसला है, the floor is open for you, ask away. Make sure you ask your question in the chat because voice is not working for some reason today. Yes. बेटा कोई मसला इस सवाल में, टॉप टू बॉटम, इज दिस क्लियर? यस, क्लियर है, आगे बढ़े. चलो लेट्स मूव अहेड भाई. स्टेट हुक्स लॉ. नाउ इससे आसान सवाल नहीं हो सकता बेटा. स्टेट हुक्स लॉ. What is Hooke's law? Will anyone in the chat define? Will anyone in the chat define what is Hooke's law? Yes, how many of you wrote the definition? Force is directly proportional to extension. Give, very good. ये definition बहुत अच्छी है. One student has written load is directly proportional to extension given that limit of proportionality isn't reached. बेटा ये ऐसी definitions लिखोगे तो A स्टार आएगा. Very good. सिर्फ ये लिख के छोड़ दोगे कि फोर्स इज डायरेक्टली प्रोपोर्शनल टू एक्सटेंशन, ऑल दो 1 मार्क का सवाल है, मिल जाएगा 1 मार्क, लेकिन अच्छा 1 मार्क नहीं मिलेगा. यू हैव टू पुट इन सम एफर्ट. चलो ये वाला सवाल रीड आउट करो एंड टेल मी व्हाट वी विल डू हियर. ये वाला सवाल रीड आउट करो बेटा एंड टेल मी व्हाट वी विल डू हियर. लेट्स टेस्ट तुम लोग की थोड़ी सी लॉजिक. ये वाला सवाल रीड आउट करो, पार्ट बी रीड आउट करो. यस, एनी जीनियसेस हु वुड लाइक टू टेल कि क्या करेंगे भाई यहाँ पे, व्हाट विल वी डू हियर? बहुत आराम से तुम लोग जो है वो मूवी देख रहे थे, अब तुम लोगों से सवाल पूछे जा रहे हैं तो चुप हो गए हो. चलो लेट्स सी हियर क्या लिखा हुआ है. द वेरिएशन ऑफ द अप्लाइड फोर्स विद एक्सटेंशन फॉर अ सैंपल ऑफ मटेरियल इज शोन इन फिगर 3.1. परफेक्ट. तो बेटा फोर्स वर्सेस एक्सटेंशन ग्राफ गिवन है. परफेक्ट. द सैंपल बिहेव्स इलास्टिकली अप टू द एक्सटेंशन ऑफ 80 सेंटीमीटर एंड ब्रेक्स एट पॉइंट एक्स. ठीक है, तो यहाँ पे जो चीजें लिखी हुई होती है ना बेटा उनको मार्क भी कर लिया करो. द सैंपल बिहेव्स इलास्टिकली टिल दिस पॉइंट, सो दिस विल बी योर इलास्टिक लिमिट. परफेक्ट. ऑन फिगर, on the line in figure 3.1, draw a cross to show the limit of proportionality. Label this cross with the letter P. अच्छा, अब इसका easiest method क्या होता है? How to identify the limit of proportionality? Do all of you have a ruler with you? बेटा रूलर लोगे और ग्राफ पेपर पे इस तरह अलाइन करोगे. You will take a ruler and align it on the graph paper like this. The point where the ruler starts to diverge, the point where the ruler starts to diverge is your limit of proportionality. As I can see here, if I zoom in here, अगर बेटा मैं यहाँ पे zoom in करता हूँ, I have to label it with letter P, right? So I think this area, this will be your P. So let's erase the line now since the work is done. Yeah, this area will be your P. Perfect. Now let's see what is the next thing that we have to do. Next thing that we have to do. Draw a cross. Okay, we have to draw a cross. ठीक है, so let's draw a cross. like this. Perfect. Okay, now the next part. You have to draw a cross to show the elastic limit. Label this cross E. Very, very easy. We already know that the cross or the elastic limit will come at this point. This is point E. Simple as that. Literally the easiest thing that you will get. Simple. चलो let's move ahead. बहुत आसान सवाल था बेटा. अगर नहीं समझ आया ask right away. The sample in B has a cross-sectional area of 0.4 millimeter square and an initial length of 3.2. Perfect. The sample in B has a cross-sectional area of this, initial length of this. Perfect. For deformations within the limit of proportionality of the sample, determine the spring constant. Okay. We have to determine the spring constant. किस तरह determine कर सकते हैं spring constant? What will you do? You will take the gradient of this graph in the limit of proportionality region. If you want to calculate the spring constant, you will take the gradient in this straight line region. Let's take the gradient in this straight line region. So I have my first point very easy. 0, 0, because it is passing through the origin. What will be my second point? My second point I will try to take as further as possible. बेटा ये अच्छा point mark हुआ है. Let's take this point. Let's take this point. This is what? This is, if this is 5, this will be 5.2, this will be 5.4. Perfect. And on the bottom on the x-axis, this will be 60. So this point is x-axis 60, y-axis 5.4. Origin is 0, 0. Can you calculate the gradient between the two? Yes, you can calculate the gradient between the two, but you will make a mistake here. You have 2 points, 0, 0. You have the second point 60 slash 5.4. Now calculate the gradient. Gradient is equals to 5.4 minus 0, 60 minus 0. You have made a mistake here. Congratulations. You have made a mistake here. Mistake क्या है? कोई identify करना चाहेगा? On the x-axis, you have your axis in millimeter. So you will multiply this 60 minus 0 with what? You will multiply this 60 minus 0 with what? You will multiply this 60 minus 0 with 10 raised to the power of minus 3 to convert it into meters. To convert it into meters. Let's see what the answer comes out to be. 5.4 divided by 60 into 10 raised to the power of minus 3. This comes out to be 90 as your answer. 90 Newton per meter is your answer. Let's see. Yeah, 90 is your answer here. Perfect. Let's further move ahead. Now you have to calculate the Young's modulus. Okay, how are you going to calculate the Young's modulus? Very, very easy. Do you remember the formula of Young's modulus? Young's modulus is equals to FL over AE. If you realize this F over E can be replaced by what? If you realize this F over E can be replaced by what? This can be replaced by the spring constant. Spring constant into the length divided by the area. Beta, what is the spring constant? 90. What is the length, original length? 3.2. Perfect. Now, what is the area? Area is 0.4 millimeter square. You will have to convert it into meter square. You will have to convert it into meter square. How? If you want to convert millimeters into meters, now this is also a regularly discussed thing. You multiply it by 10 raised to the power of minus 3. If you want to convert millimeter square into meter square, what will you do? You will multiply it by 10 raised to the power of minus 3 square. That is equals to 10 raised to the power of minus 6. This comes out to be what? 0.4 into 10 raised to the power of minus 6. What will your answer be? 90 into 3.2 divided by 0.4 into 10 raised to the power of minus 6. This value comes out to be what? बेटा ये value क्या आ जाती है? This value comes out to be 7.2 into 10 raised to the power of 8 pascals. Simple. Nothing complicated here. Let's further move ahead. Determine an estimate of the work done on the sample as it is extended from zero extension to the breaking point. Explain your working. Perfect. So you have to calculate the work done on the sample from zero extension till its breaking point. So basically you have to calculate what? You have to calculate the area under the graph. You have to calculate the area under the graph. How can you calculate the area under the graph? Hmm. How can you calculate this entire area under the graph? Beta, this shape looks familiar. This shape looks familiar. This shape is basically a trapezium. You can approximate this shape to be a trapezium. Beta, you can approximate this shape to be a trapezium. Okay. Let's say. Chalo, let's say this is the. Now let me highlight it. Let's say this is the first parallel side of the trapezium. This is the second parallel side of the trapezium. Let's calculate both of them. The first parallel side will be, yeah, this is 5.9 and this will be 7, this will be 6.8. Perfect. So the two parallel sides of the trapezium are what? This is 6.8 and this is 5.9. Perfect. Okay, now what else do we have to do here? We also have to calculate the height. The height will be equal to this value. The height will be equal to this value, which is roughly equal to what? This will be, okay, we will have to calculate the scale here. थोड़ा सा zoom in करके ना scale पे focus कर लेते हैं यहाँ पे. From 160 to 140, you are covering 40 units in 10 boxes. You are covering 40 units in 10 boxes. One box will cover how many unit? 4 units. So this will be 200 minus 8. This will be 192. Perfect. So the height is 192. This is 192. Can you calculate the area of the trapezium? Yes. You have the two parallel sides. You have the height as well. Can you calculate the area of the trapezium? Yes, very, very easy. You will say 1 upon 2 into sum of parallel sides, that is 5.9, plus 6.8 multiplied by the height, that is 192. Now, please don't forget that this is millimeter. So you will multiply it by 10 raised to the power of minus 3. Can any genius in the chat tell me the answer to this one? 5.9 plus 6.8 into 192 into 10 raised to the power of minus 3 divided by 2. Yeah, this comes out to be 1.2. This comes out to be 1.2 joules as your answer. Simple as that, nothing complicated. बेटा कभी कभार एग्जामिनेशन में you will have to calculate the area, approximate area as well. So you can calculate it like this. You can calculate it like this by assuming the shapes that perfectly fit this graph. अच्छा अब ये वाला पार्ट हमने कहाँ पे रखना था? 1 second, let me put this part here. Perfect. चलो let's see part E. Part E looks interesting because it is related to theory. A second sample of the same material. Now, what does the examiner imply by the same material? Same Young's modulus, or you can say same E, has a larger cross sectional area. Perfect. Area is greater. Perfect. Then the original sample, but the same initial length. Okay, the length is also same. Perfect. The two samples are each deformed within the limit of proportionality. Perfect. State and explain qualitatively how the spring constant of the second sample compares with that of the original sample. Beta, I need your undivided attention on the board. I need your undivided attention on the board. Do you remember that Young's modulus is equals to what? FL over AE. Now, F over E is represented by what? F over E is represented by what? It is represented by spring constant. Perfect. Now, please pay attention, analyze each thing very carefully. If you notice, Young's modulus is constant. If you notice, length L is same L. So, can you do this? Can you say this that Young's modulus and L are constant? So, you can take area to this side. Area E over L is equals to K. This entire thing is constant. So, you will say area is directly proportional to the spring constant. What will be your final answer now? What will be your final answer now? You will say spring constant is directly proportional to area. Spring constant is directly proportional to area. Is directly proportional to what? Is directly proportional to area. Hence, hence, as hence as we will say as a spring constant is directly proportional to area, hence as the second sample has larger area, hence as the second sample has larger area, it will have a larger spring constant. आ गई बात समझ? इस पूरे क्वेश्चन में कोई मसला? लेट मी जूम आउट अ बिट। इस पूरे सवाल में कहीं भी कोई भी मसला है, यू कैन आस्क मी राइट अवे। कोई सिंपल सा भी मसला है, यू कैन आस्क राइट अवे। क्लियर है? आगे बढ़े भाई, चलो आगे बढ़ते हैं। लेट्स मूव अहेड। या लेट्स सी दिस। अ प्रोग्रेसिव ट्रांसवर्स वेव, यू कैन से दैट, हाँ यू कैन से दैट, यू कैन से दैट एज वेल। यस यू कैन से दैट। चलो लेट्स सी दिस। अ प्रोग्रेसिव ट्रांसवर्स वेव ट्रैवलिंग फ्रॉम लेफ्ट टू राइट इज शोन एट एन इंस्टेंट इन टाइम इन फिगर 4.1। परफेक्ट। ये एक प्रोग्रेसिव ट्रांसवर्स वेव है, ठीक है। वी हैव टू कैलकुलेट द फेज डिफरेंस बिटवीन पॉइंट आर एंड टी। भाई आर और टी के बीच में फेज डिफरेंस निकालना है। नाउ फॉर दिस यू हैव टू अंडरस्टैंड वन थिंग। बेटा फॉर दिस you have to understand one thing. One complete wave represents a phase difference of what? One complete wave represents a phase difference of what? 360 degree. Perfect. So beta, if I break this wave into four quarters, if I break this wave into four quarters, let's say this, this, and this again. Each quarter will have a phase difference of 90 degree, 90 degree, 90 degree, 90 degree. If one complete wave represents a phase difference of 360 degree, अगर आप उस वेव को चार क्वार्टर्स में डिवाइड करो, द फेज डिफरेंस फॉर ईच क्वार्टर विल बी 90 डिग्री. Let's apply the same logic here. Let's apply the same logic here. Let's see points R and T. बेटा points R और T को देखते हैं. This is 90 degree. This is further 90 degree. This is further 90 degree. 390 degrees कितना ऐड अप हो जाएंगे? 90 plus 90 plus 90. The total phase difference is 270 degrees. Simple. On figure 4.1, draw an arrow at point T to show the direction of movement of point T at the instant shown. अब ये हमने MCQs में बेटा इतनी दफा किया है कि ये रट जाना चाहिए. You have to show the direction of movement of point T. Yes. कभी भी ट्रांसवर्स वेव पे इफ यू हैव टू कैलकुलेट द डायरेक्शन ऑफ मूवमेंट, व्हाट डू? यू फर्स्ट ऑफ ऑल ड्रॉ एन इमेजिनरी लाइन. आ गई इमेजिनरी लाइन भाई. फिर ये जो पीछे वेव आ रही है उसको रेप्लिकेट कर दो. रेप्लिकेट दिस वेव लाइक दिस. सिंपल. तो इस तरह अगर मूवमेंट होगी तो दैट मीन्स टी इज मूविंग व्हाट? टी इज मूविंग डाउनवर्ड. टी इज मूविंग डाउनवर्ड. सिंपल. The horizontal distance between R and T is 0.62 centimeters. Perfect. The wave has a speed of this. Perfect. Calculate the frequency of the wave. Again, फिर से वही logic apply करो. If one quarter, second quarter, okay. Let me do it with a different color. ये first quarter हो गया, ये second quarter हो गया, this is the third quarter. If three quarters of a wave, if three quarters of a wave are equal to 0.26 centimeter, how much will one lambda be equal to? Place an x here. Calculate कर लो cross multiply करके. X comes out to be what? X comes out to be what? 0.62 into 4 over 3. 0.62 into 4 over 3, your lambda comes out to be what? Calculate करो जरा क्या आता है. Your lambda comes out to be 0.82, 0.827 centimeters. Simple. This is your lambda. Simple. Sir, can you tell how to calculate the direction of the wave? बेटा बहुत easy है. देखो, ट्रांसवर्स वेव में आपको किसी भी पॉइंट की डायरेक्शन ऑफ मूवमेंट निकालनी हो, ट्रांसवर्स वेव में आपको किसी भी पॉइंट की डायरेक्शन ऑफ मूवमेंट निकालनी है, आप क्या करोगे? लेट से मुझे पॉइंट टी की निकालनी है. आई ड्रॉ अ डॉटेड लाइन हियर, इमेजिनरी डॉटेड लाइन. और बेटा ये जो पीछे वेव आ रही है उसको रेप्लिकेट कर दूंगा आगे. बिल्कुल पीछे जो वेव आ रही है उसको रेप्लिकेट कर दो आगे इस तरह. सिंपल. So I have done the same thing. Once I replicated the wave, I got to know that t will move downward. So I have drawn an arrow downward. Simple. Nothing complicated here. चलो यहाँ पे हमें पता चल गया कि lambda is 0.827 centimeter. Perfect. The speed of the wave is this. Perfect. Now first and foremost you have to calculate the frequency. V is equals to f lambda. V is 0.27. Now, how will you put your lambda? You cannot put it in centimeters. 0.827 into 10 raised to the power of minus 2 to convert it into meters. 0.27 divided by 0.827 into 10 raised to the power of minus 2. What does your frequency come out to be? बेटा frequency क्या आ जाती है? Frequency comes out to be 33 hertz. Frequency comes out to be 33 hertz. Simple as that, nothing complicated here. Let's further move ahead. The wave is a water wave produced by a dipper S1. Perfect. Attached to a vibrator in a ripple tank. Perfect. An identical dipper S2 is attached to the same vibrator. The two dippers produce an interference pattern of the water in the tank as shown in figure 4.3. बेटा ये एक इंटरफेरेंस पैटर्न प्रोड्यूस हो रहा है. The wave crests from each source are represented by solid lines. अच्छा, ये जो crest है वो represent हो रहे हैं by solid lines. And the wave turns are represented by dash lines. Perfect. तो बेटा जिनका थोड़ा सा IQ अच्छा है वो आइडेंटिफाई कर लेंगे कि ये कौन से एक्सपेरिमेंट की बात हो रही है. This is an indirect representation of Young's double slit experiment. चलो let's see. At point P in figure 4.3, okay, at point P in figure 4.3, the wave S1 has amplitude A. The wave from S1 has the same amplitude as the wave from S2. Describe and explain the resultant amplitude of the wave at point P. अच्छा, पॉइंट पी को देखते हैं भाई. पॉइंट पी पे फोकस करेंगे क्या हो रहा है. नाउ इफ यू सी पॉइंट पी पे क्या हो रहा है बेटा, इफ यू सी पॉइंट पी पे क्या हो रहा है, इफ यू सी पॉइंट पी पे एक क्रेस्ट, मतलब S1 का क्रेस्ट, इसको मैं रेड से मार्क कर देता हूं. S1 का क्रेस्ट is meeting with the turf of S2, is meeting with the turf of S2. बेटा जब एक क्रेस्ट और टर्फ मीट करते थे, दे आर व्हाट, आउट ऑफ फेज पॉइंट्स. और जब भी आउट ऑफ फेज पॉइंट्स मीट करते थे यू हैव डिस्ट्रक्टिव इंटरफेरेंस. And whenever you have destructive interference, आपका resultant amplitude क्या होता था? कम. So you can write all of this here. You can write all of this here. You can say at point P, at point P, at point P, the crest of S1 meets the turf of S2, simple, meets the turf of S2, giving rise to destructive interference. Giving rise to destructive interference. Giving rise to destructive interference. The resultant displacement or the resultant amplitude, or you can say the resultant displacement. Resultant displacement I guess will be a better word क्योंकि amplitude I have told earlier as well वो बड़ी specific सी term है. The resultant displacement will be the sum of individual displacements. Perfect. The resultant displacement will be the sum of individual displacements. Perfect. Hence, the resultant amplitude at P is 0. भाई रिजल्टेंट एम्पलीट्यूड एट पी जीरो क्यों होगा? बिकॉज एस वन का एम्पलीट्यूड इज ए, एस टू का एम्पलीट्यूड विल बी नेगेटिव ए, दोनों को ऐड करोगे तो जीरो हो जाएगा. सिंपल. लेट्स मूव अहेड. स्टेट किरचॉफ सेकंड लॉ. किरचॉफ सेकंड लॉ क्या होता था बेटा? सम ऑफ इलेक्ट्रोमोटिव फोर्सेज इज इक्वल टू द सम ऑफ पोटेंशियल डिफरेंसेज अराउंड अ लूप. Sum of EMFs is equals to sum of potential differences across a loop. Simple. State the conservation law that gives rise to Kirchhoff's second law, conservation of energy. Conservation of energy. Simple as that. Let's further move ahead. A circuit contains a cell of internal resistance R and two resistors of resistance R1 and R2 as shown. Perfect. The potential difference across the two resistors is V. The current in the cell is I. Perfect. So you can say this is V, this is V. The current in the circuit is I. Perfect. Use Kirchhoff's law to show that the total resistance of the external circuit is given by this. You have to show using Kirchhoff's law that the total resistance of the circuit is given by this formation. Okay. So how will we do that? We will say that the voltage across the two resistors is same. V1 is equals to V2 is equals to the voltage in the battery. Perfect. What will be your second task? You will say that the current I is equals to, let's say this is I1, this is I2. You will say current I is equals to I1 plus I2. What will you do next? You will say V is equals to IR. V divided by R is equals to I. Perfect. Current I is equals to V over the total resistance T. Voltage V1 divided by the resistance R1 plus voltage V2 divided by the resistance R2. Let's take voltage as common 1 over RT is equals to voltage as common 1 over R1 plus 1 over R2. VV cancel out. What will be your final answer? 1 over RT is equals to 1 over R1 plus 1 over R2. Simple. Derivation done. Let's move ahead. The electromotive force is 1.5 volts. When the values of R1 and R2 are 10 and 15 ohms, the potential difference measured is this. कैलकुलेट द इंटरनल रेजिस्टेंस ऑफ द सेल। बहुत अच्छा सवाल है, वेरी वेरी इंटरेस्टिंग क्वेश्चन। सो योर ईएमएफ ऑफ द सेल इज व्हाट? Your EMF of the cell is 1.5 volts. Perfect. And basically, the voltmeter is reading 1.3 volts. So the resistors are having 1.38 volts. Internal resistance को बेटा कितना voltage मिलेगा? 1.5 minus 1.38. This is 0.12 volts. Simple. Now, what will be the current? What will be the current? How will you calculate that? How will you calculate the current I1? Because you have to calculate the internal resistance smaller. You can only calculate that if you know this value of current. How will you do that? You can calculate the total resistance of R1 and R2. What will be the total resistance of R1 and R2? Very, very easy. 1 over R total is equals to 1 over 10 plus 1 over 15. Can you calculate the total resistance? By putting it in the calculator. 1 over 10 plus 1 over 15. 1 divided by answer. This comes out to be 6. Total resistance is 6 ohms. Perfect. Total resistance is 6 ohms. वोल्टेज क्या है बेटा? 1.38। तो क्या आप ये वैल्यू ऑफ करंट निकाल सकते हो? यस। V is equals to IR. Voltage is 1.38. Resistance is 6. What will be your value of current? Calculate it. 1.38 divided by 6. This comes out to be 0.23. 0.23 ampere is your current. Now you have your current as well. You have your voltage as well. Can you calculate the internal resistance? Yes. V is equals to IR. Voltage is 0.12, current is 0.23, resistance small comes out to be what? 0.12 divided by 0.23, this comes out to be 0.52 ohms as your answer. बेटा आपकी इंटरनल रेजिस्टेंस आ गई 0.52 ohms. Simple. Yes, anyone that finds this difficult. A third resistor is added in parallel with R1 and R2 in the circuit in figure 5.1. State and explain the effect, if any, of this change on the current in the cell. भाई अगर आप तीसरा रेजिस्टर पैरेलल में लगाओगे तो करंट किस तरह इफेक्ट हो बताओ. इफ यू आर कनेक्टिंग अ थर्ड रेजिस्टर इन पैरेलल, थोड़ी सी दिमाग लगाओ और मुझे बताओ कि क्या होगा. ये बहुत ज़्यादा कलरिंग कर दी हमने यहाँ पे. राइट से रहते, अगर हम एक तीसरा रेजिस्टर यहाँ पे लगा रहे हैं, एक थर्ड रेजिस्टर इन पैरेलल, व्हाट विल हैपन? टोटल रेजिस्टेंस क्या करेगी बेटा? टोटल रेजिस्टेंस डिक्रीजेस. टोटल रेजिस्टेंस ऑफ द पूरा कॉम्बिनेशन डिक्रीजेस. अब आप कहोगे सर ये तो बहुत ही काउंटर इंटुइटिव बात है. बेटा कभी भी फिजिक्स में कोई भी चीज़ काउंटर इंटुइटिव नहीं होती. आप प्रूव कर सकते हो. थोड़ा सा हमारे पास टाइम है आज, तो आप प्रूव कर सकते हो इसको. लेट से ये एक 1 ओम का रेजिस्टर है. लेट से एक ये 1 ओम का रेजिस्टर है. ये दो रेजिस्टर्स हैं, इनकी पैरेलल में कंबाइंड रेजिस्टेंस क्या हो जाएगी बेटा? 0.5. हाउएवर अगर आप 3 1 ओम के रेजिस्टर लगा दो, देखो ये काउंटर इंटुइटिव बात नहीं है. अगर 3 1 ओम के रेजिस्टर एक साथ लगा दो, आई एम जस्ट ड्राइंग अ रफ स्केच, तो आपकी टोटल रेजिस्टेंस क्या हो जाएगी? 0.33 ओम. तो जितने आप रेजिस्टर्स पैरेलल में लगाते रहते हो, काउंटर इंटुइटिव बात है कि आप रेजिस्टर ऐड कर रहे हो लेकिन टोटल रेजिस्टेंस कम हो रही है. सो करंट विल इंक्रीज. यू कैन राइट हियर as the total resistance decreases, the current will increase. The current increases. Simple as that. अब पार्ट 2 पे आ जाओ भाई. पार्ट 2 में क्या लिखा हुआ है? What is written in part 2? क्या लिखा हुआ है? पार्ट 2 में क्या लिखा हुआ है? You have to tell what will happen to क्या? You have to tell what will happen to the potential difference measured across the voltmeter. बेटा मुझे विथ शो ऑफ हैंड्स सच्ची सच्ची बताना, किस किस ने इलेक्ट्रिसिटी वाले लेक्चर्स देखे हैं, किस किस ने इलेक्ट्रिसिटी वाले लेक्चर्स देखने की जहमत भी की है, और कौन जो है वो बिल्कुल ही इलेक्ट्रिसिटी वाले लेक्चर्स देख के नहीं आया हुआ. देख के आए हो? परफेक्ट है। बस। चलो। गुड 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 गुड। कोई परफेक्ट परफेक्ट। इलेक्ट्रिसिटी वाले लेक्चर्स देख के आए हो, अल्हम्दुलिल्लाह। तो ये तो बहुत आसान होने नंबर। अच्छा, करंट इंक्रीज कर रहा है। हम्म। करंट इंक्रीज कर रहा है। अब थोड़ी सी मैं इलेक्ट्रिसिटी वाले लेक्चर का रेफरेंस दूंगा, अगर नहीं समझ आता तो मुझसे पूछ लेना, कोई इसमें घबराने की बात नहीं है। अच्छा जी। ओहो, ये क्या हुआ? 1 सेकेंड। अब थोड़ा सा ना फोकस करेंगे। और ये जो हमने डेरिवेशन की है, ये बहुत ज़्यादा स्पेस ले रही है, इसको हम यहाँ पे रख दें। परफेक्ट। सो इन जो इलेक्ट्रिसिटी का लेक्चर है, मैंने एक चीज़ बताई थी, जो आपका ईएमएफ है वो दो चीज़ों में डिवाइड होता है, और अभी भी हमने उसको थोड़ा थोड़ा डिस्कस भी किया था। ईएमएफ दो चीज़ों में डिवाइड होता है। एक है टर्मिनल पोटेंशियल डिफरेंस, एंड द अदर वन इज लॉस वोल्ट्स। द अदर वन इज लॉस वोल्ट्स। ये इसलिए बता रहा हूँ क्योंकि हो सकता है किसी की इलेक्ट्रिसिटी की नॉलेज अभी भी कमज़ोर हो। अच्छा, ईएमएफ दो चीज़ों में डिवाइड होता है, टर्मिनल पोटेंशियल डिफरेंस एंड लॉस वोल्ट्स। परफेक्ट। अच्छा, अब what is loss volts? What is terminal potential difference? Terminal potential difference is the voltage across the external circuit. एक्सटर्नल सर्किट में जो वोल्टेज होता है उसको टर्मिनल पोटेंशियल डिफरेंस कहते हैं। और जो इंटरनल रेजिस्टेंस में वोल्टेज यूज होता है उसको लॉस वोल्ट्स कहते हैं। परफेक्ट। दोनों को निकालते किस तरह में? एक्सटर्नल सर्किट का वोल्टेज किस तरह निकलेगा, टर्मिनल पोटेंशियल डिफरेंस किस तरह निकलेगा? करंट इनटू द टोटल रेजिस्टेंस ऑफ द एक्सटर्नल सर्किट। लॉस वोल्ट्स किस तरह निकलेगा? करंट इनटू इंटरनल रेजिस्टेंस, सिंपल। बेटा, अगर आपका करंट इंक्रीज हो रहा है, अब थोड़ा सा गौर करना, ठीक है? करंट इंक्रीज हो रहा है, इंटरनल रेजिस्टेंस तो वही रह रही है। करंट इंक्रीज हो रहा है, इंटरनल रेजिस्टेंस वही रह रही है, तो आपका लॉस वोल्ट्स क्या करेगा? इंक्रीज कर जाएगा। और अगर आपका लॉस वोल्ट्स इंक्रीज कर रहा है, लेट से इसको इनिशियली 0.12 वोल्ट्स जा रहे थे, अब इसको 0.2 वोल्ट्स जा रहे हैं, तो एक्सटर्नल सर्किट में जो वोल्टेज आएगा वो कम हो जाएगा। लेट से पहले एक्सटर्नल सर्किट में 1.3 आ रहा था, वो 1.38 आ रहा था, अब 1.3 आएगा। तो यही लिख दो, हेंस आपकी वोल्ट मीटर की रीडिंग क्या करेगी? डिक्रीज। यू विल से as current increases, you will say as current increases, क्या होगा? As current increases, what will happen? As current increases, your loss volts increase, और loss volts increase होंगे तो क्या होगा? टर्मिनल पोटेंशियल डिफरेंस डिक्रीज। टर्मिनल पोटेंशियल डिफरेंस डिक्रीज होगा तो क्या होगा? वोल्ट मीटर की रीडिंग डिक्रीजेस। सिंपल एज दैट। बेटा, ये सवाल समझ आया? ये सवाल हर साल रिपीट होता है। ये पार्ट 2 जो है ना, वो हर साल रिपीट होता है। तो मुझे बता दो अगर नहीं समझ आया तो। लिटरली आई एम नॉट इवन एग्जैजरेटिंग इट, ये हर साल रिपीट होता है। क्लियर हो गई ये बात? चलो आगे बढ़ते हैं, लेट्स मूव अहेड। आप कोई भी एयरली पास पेपर देखोगे ना, उसमें ये सवाल रिपीट हुआ हुआ होगा। आई डोंट नो व्हाई, लेकिन हाँ, रिपीट होता है। न्यूक्लियस ऑफ एन आइसोटोप ऑफ Sm each contains 62 protons and 85 neutrons. State the nuclear notation in the form AZX for the isotope of Sm. किस तरह स्टेट करेंगे भाई इसकी न्यूक्लियर नोटेशन? वेरी वेरी इजी। बेटा, हमेशा हमेशा बॉटम पे क्या आता है? प्रोटॉन नंबर, दैट इज 62। टॉप पे क्या आता है? प्रोटॉन नंबर प्लस न्यूट्रॉन नंबर। टॉप पे क्या आता है? प्रोटॉन नंबर प्लस न्यूट्रॉन नंबर। 62 प्लस 85, this comes out to be what? 147. This comes out to be 147. Perfect. This isotope of Sm is radioactive and decays by emitting particles. Perfect. Gamma radiation is not emitted. The energy spectrum of the emitted particle is shown in 6.1. बेटा, जो पार्टिकल ये इमिट कर रहा है ना, उसका एनर्जी स्पेक्ट्रम आपको गिवन है। क्या लगता है कौन सा पार्टिकल होगा? यू कैन सी दैट द काइनेटिक एनर्जी इज रिमेनिंग कांस्टेंट। यू कैन सी दैट द काइनेटिक एनर्जी, ओ सॉरी, हाँ माय बैड, मेरी गलती है भाई। एक्स नहीं आएगा यहाँ पे, एस एम आएगा, सॉरी माय बैड। यहाँ पे एक्स नहीं आएगा बेटा, यहाँ पे एस एम आएगा, माय बैड। चलो लेट्स सी द नेक्स्ट वन। Explain how figure 6.1 shows that the isotope of Sm emits alpha particles and does not emit beta particles. बेटा हमें कैसे पता चल रहा है कि that this emits alpha particles and not beta particles? बेटा पार्टिकल फिजिक्स में मैंने एक छोटू सा की पॉइंट लिखवाया था, एक बहुत ही छोटा सा की पॉइंट लिखवाया था जिसको पता है मुझे इग्नोर करने वाले हो तुम लोग। That is, beta particles have a range of kinetic energies और अल्फा पार्टिकल्स की काइनेटिक एनर्जी क्या होती है? कांस्टेंट या सेम। तो यहाँ पे यही दिख रहा है भाई, काइनेटिक एनर्जी आपकी क्या है? कांस्टेंट या फिर सेम। हेंस दीज आर अल्फा पार्टिकल्स। बीटा पार्टिकल्स की काइनेटिक एनर्जी क्या करती है? वेरी। सो यू कैन राइट दिस हियर, you can write this here. The kinetic energy of the particles is constant, or you can say it has only one value. Hence, these are alpha particles. और बीटा पार्टिकल्स का भी साथ लिख दो कि बीटा पार्टिकल्स हैव अ कंटिन्यूअस रेंज ऑफ काइनेटिक एनर्जी, सिंपल एज दैट, यू कैन राइट इट हियर। बीटा पार्टिकल्स, बीटा पार्टिकल्स have a continuous range of kinetic energies. Hence, they are not emitted as seen from the graph. As seen from graph. However, however, alpha particles have a constant kinetic energy, have a constant kinetic energy, which can be seen in the graph, which can be seen in the graph. Simple as that, nothing complicated here. आगे बढ़े भाई, चलो आगे बढ़ते। द आइसोटोप एस एम डिकेज टू एन आइसोटोप ऑफ neodymium. The isotope Sm decays into an isotope of neodymium. Give the radioactive decay equation for this decay. Include the nucleon and proton numbers for all the particles involved. बेटा अब हमें पता है ये जो एस एम आइसोटोप है ये अल्फा डिके करता है, तो व्हाट विल यू से? एस एम, इसका सिंबल क्या था? एस स्मॉल एम या एस स्मॉल एम 62 147, एस स्मॉल एम 62 147 decays by what? It decays by emitting an alpha particle, 4 2 alpha particle, plus whenever you emit an alpha particle, your mass number decays by 3 and proton number decreases by 2. nd का सिंबल यहाँ पे लिख दो, सिंपल। लेट्स further move ahead. A boron is composed of three quarks which all have different flavors. The boron has a charge of 0, perfect. Two of the quarks in the boron are up quark and a bottom quark, perfect. Determine in terms of the elementary charge the charge of the third quark. बेटा अगर आपने जीरो का चार्ज बनाना है, अगर आपने जीरो का चार्ज बनाना है, अप कॉर्क हैज अ चार्ज ऑफ 2/3, बॉटम कॉर्क हैज अ चार्ज ऑफ -1/3, तो सेकेंड या थर्ड कॉर्क का चार्ज क्या होना चाहिए? What should be the charge of the third quark to create a zero? The charge on the third quark should be -1/3e. The charge on the third quark should be -1/3e. State a possible flavor for the third quark, maybe a down quark. Simple. This marks the end of this paper. बताओ ये बात समझ आई? ये वाला सवाल समझ आया? फिर आगे बढ़ते हैं।